Um, okay, so welcome to class. It's great to see everybody both online and in person. The Nearpod code is on our shared screen. If you would kindly go ahead and join, make sure you're joining the Nearpod code, that would be great. Um, so, um, if you're in person, so my folks who are in person, you all know that you have to sign up. You're supposed to sign up for a wellness pod. So that's the link that's in the Nearpod right now. So for my in-person people, every morning between 7:25 and 9:25, we need to complete that Google form for a wellness pod. And the purpose is so the cafeteria can plan how many lunches they need to get. So our lunch and wellness break is from 11:15 to 12:15. To keep students in smaller groups, students can pick from a list of rooms they'd like to spend time when they're not eating, and that's called a wellness break. So that's why we sign up in that Google form. We have lunch from 11:15 to 12:15. And students can eat anytime during that hour time frame. So you can eat right at 11:15, you can eat right at, 12 o'clock, you can eat at any time during that frame, and then they're going to give you reminders to get food over the PA. These are the only places where students are allowed to eat. So it's these 5 places. So you can only eat in the cafeteria, courtyard, patio, stadium, hallway by the cafeteria. And then the wellness pods will change from day to day. So every day you're in person, you'll be asked to sign up for one. So you might want to, check with your friends, see what they're doing, and see if you can join the same wellness pod. All right. So I think that about covers it. We already did the survey, and then you can always find the link to sign up on the Wheaton website. So if your first period teacher forgets, or if I forget, you can always find it on the website. Okay. There's also water stations. So you should have gotten a Wheaton water bottle. There's one right outside my classroom. Like if you go out and to the left, there's a big water filling station you'll see. There's also one on the first floor in the cafeteria, second floor outside of 2123, and then a couple in up here in the third floor. And then you can also bring your own water bottle from home, but the water fountains have been turned off. So that's just for you guys to know. And then obviously you guys know this already. If you leave the campus at any time during the day, you can't return. So just so you know that. Okay. So that's it for the logistics in terms of people coming back in person. I want to give you a couple more minutes, or not a couple more minutes, but another minute to join the Nearpod. The code is on the shared screen, D9YME. So make sure you're in there. I see 4 students in, and it should be like 15. So go ahead and take another minute to just make sure you get into that Nearpod, and then we'll get started in just a few minutes or seconds. Let's take 30 seconds to make sure you're in that Nearpod. So I see that, let's see. Denzel is in, Elijah's in, Jefferson's in, Sharon's in, Wesley's in, Brianna's in. So great. All right. Let's go ahead and make sure you're in. All right, so I think that's most people in. Awesome, thank you. All right, let me go ahead and proceed. So today what we're going to be doing is, today and Friday is law of sines, law of cosines. So basically we've been doing like right triangles, like double angle, half angle. Like when you have a right triangle, how do you find the different pieces of it? So today what we're going to be doing is studying when you don't have a right triangle and how you find pieces of it anyway. So this is going to be a big calculator heavy week. There's a scientific calculator linked here if you want to use here where it says graphing or scientific. I do invite you to, if you want to click on scientific, you're welcome to. Make sure your calculator is in degree mode, okay? So we have a warm up. We're gonna frame the learning objective for you guys, which is what I just did. We'll do the proof of law of sines, example problem, practice problem, and then proof of area formula. You guys will do a practice problem with that. You'll have some workshop time to work on your assignment, and then we'll close with a multiple choice, it's like 4-question exit card. Okay, so you'll need Zoom unless you're in person, then you don't need Zoom. You can just do Nearpod. The code is here again, D9YME. It's helpful to have a formula sheet open if you want, pen and paper to take notes if you're that kind of note taker, and then a calculator. And then we have a homework and a formative this week. Okay. Any questions I can answer right now? All right. So go ahead and get started on the warm up. So it's matching each term with its definition. And this is sort of like a pre-assessment for me to see what you understand so far. So it's in the Nearpod. So go ahead and do your matches. Take about a minute, see if you can do these matches. And it's okay if you don't get them right. It'll let you keep trying until you have them all right. But this is really just for me to see what you all remember. Good morning. Good morning. I think all right, so it's looking good. A lot of people have 9 out of 9. We got some 8 out of 9s. Let me give it another like 30 seconds, and then we'll move ahead. Really proud of you all for persisting with it. This is great. Y'all are doing great. Okay. All right. So all right. So to match the pairs, right triangle is a triangle that has one right angle. Sine is the length of the side opposite the angle divided by the hypotenuse. Cosine is adjacent over hypotenuse. Tangent's opposite over adjacent, and opposite is the side across from the angle. The longest side of a right triangle across from the right angle is the right triangle, or sorry, the hypotenuse. And then we had law of cosines is the one that starts with c squared. Law of sines is the one with the division signs, and then adjacent is the side next to the given angle. Okay, so we're going to practice more with that today. I'm going to go ahead and go forward in the slides. If you're still looking to join the Nearpod, I have the code on the slide. So if you are in the Zoom and you want to look for that, or if you're in person, you want to look up here for it, you can find it. Okay, so let's go ahead and go forward. So what we're looking at today is the law of sines and the area formula. We'll do law of cosines next time on Friday, but law of sines we'll do today. So again, like I said before, this is like non-right triangle trig. It's like if you have a triangle and it's not a right triangle, how do you find the sides and the missing angles, right? Okay, so what I'm going to do is I'm going to go through a proof of the law of sines with you. And I'm going to do this on my document camera, and I'm just going to hope that it works nicely so that you all can see. Nope, only the people on Zoom can see. All right, let's try this again. I'm going to actually move the whole Zoom over here, and then I'll share that way so that you all can see. All right, so this proof is kind of already filled out in the Nearpod, but I think sometimes it's easier to see it worked out. So what I'm going to do is I'm just going to draw a triangle. Whoa. Let's see, let me turn this off, and then I'm going to turn this lamp on and see if that helps you guys see it if you're in person. All right, so let's say we have this right triangle, okay, and it's not a right triangle. We don't know what we know that it's not a right triangle. So we have triangle A, and if you want to take notes, feel free. This is also in the slides. So we have triangle ABC. Usually the way we label sides is the opposite the angle is just that lowercase. So we have angle A here, right? And then we have side A here. Okay, can you all see that okay? All right. So opposite B would be side B, and then opposite C, we'll just call that side C. Okay, so triangle, there it is, it's just there. Okay, and we want to know what the side lengths are. So what you can do is you can drop down a right angle, like a line that actually is a right angle to the base right here, and we'll call that H because it's kind of like the height of the triangle, right? So this is the height of the triangle, okay? So if we look at angle A, okay, if we look at angle A, let's just take, this is angle A. So the sine of angle A, like this is theta, right? This is the angle. The sine of A is H over B, right? Opposite over hypotenuse, okay? And then the sine of B, let's just take this little angle, this angle here. The sine of angle B is the hypotenuse over side A. Or not hypotenuse, I mean H, like height, not hypotenuse, sorry about that. I'm not woken up yet. Okay, right? So opposite over adjacent, because this is a little bitty right triangle and this is a little bitty right triangle. So here's your angle. The sine is h over b. Here's your little angle. Sine is h over a. Okay. So if we solved both of these equations for h, we'd have that b sine of a is equal to h, right? And a sine of b is equal to h. Right, so if these two are equal, then we can say that b sine a is equal to a sine b. And then we can say that basically we can divide, right, if we divided both sides by, say, sine a, and we divided both sides by sine b, because you're doing the same thing to both equations, you have that b over sine b is equal to a over sine of a. Okay. Or you could go the other way around. You could set them equal to each other and divide by the sides instead and say that sine of b over b equals sine of a over a. Okay. And that will work too if you use c. If you turn the triangle and draw a height that drops down this way, and you have the same pattern, sine of c equals h over b, sine of b equals h over c. So the law of sines is basically saying that this proportion is going to be true for any non-right triangle or any right triangle, any triangle, okay? So the law of sines tells us that sine of a over a equals sine of b over b equals sine of c over c. And it works the other way around with the reciprocals. A over sine a equals b over sine of b, which equals c over sine of c. Okay, dun, 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 dun. You don't have to memorize this. It's going to be in your formula sheet. But that is the proof of why this works. It goes back to right triangles and the sine of angles. Okay, let me stop talking because that was a lot. So, but let me pause and see if you have any questions. If you need to write it down, feel free. So I'll do an example with you and then I'll have you practice one. So let me give you an example. So law of sines, we really can only use it when we have angle, side, angle, 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 side, and side, side, angle. These are like the three cases because we need an opposite pair. We need a matching pair in order to use it. Like we have to have both the angle and the opposite side in order to actually use it. So we basically need a matching angle side pair, okay? So what I'm gonna do is in the next slide in the Nearpod, there's an example problem and I'm gonna demonstrate it for you and then I'll have you all practice one. So here we go. We have, I'm just copying down what's in the Nearpod. So we have an angle, angle, side triangle. And this is 81 degrees, 83 degrees, and it's triangle A, B, C. Here is C, and then side A is 9 centimeters, and then we have to find side B. Okay. So if you're taking notes, feel free to take a moment to write that down. If you're just looking in the Nearpod or taking notes in the Nearpod, that's fine too. Okay, so solve the triangle means we're finding everything. We're finding all the angle measures and we're finding all the sides. Okay, it's actually to find the missing angle measure. Does anyone remember like how many degrees are in a triangle? Like what should all the measurements of all three angles in a triangle, what should they add up to? Does anyone remember from geometry? Go ahead. 180. So triangles, the angles must add up to 180. must add up to 180. So what do we think the missing angle is going to be? If this is 83 and this is 81, what's the missing angle? Take your time. Okay, getting some good responses in the chat. Anyone else figure it out? So if we do 180 minus 83 minus 81, we get okay, good. So a couple people got that it's 16. So the missing angle measure, I'm going to start writing in a different color. So the missing angle measure is 16. So angle C is 16. Okay. So I found all the angles. Now I just need to find the sides. So let's start. It doesn't matter where we start. Let's try to find side B. Let's just go in alphabetical order, right? So the law of sines says that I can either do B over sine B equals A over sine A, or I could do sine B over B equals sine A over A. Since I'm trying to find the sides, I'm going to go with this version. I'm going to go with the one that has the sides on top. Okay. And my matching pair that I see is A and A, right? That's given to me. This is the one side length I have and then the opposite angle. So that's going to be my anchor that I'm going to use to solve the problem. Okay. So I'm going to use this version of the formula. So I have 9 over sine 81 equals, and I don't know what B is, so I'm going to leave B here, over sine of 83, right? Because it has to just be the opposites, right? To solve for B, I can multiply both sides by sine of 83, sine 83. So 9 sine 83 over sine of 81 will be my side B. Okay. So you can use your Desmos calculator. Since I'm screen sharing on the document camera, I'm going to use a calculator. But 9 sine 83, close parentheses, over sine 81, close parentheses, is 9.044 centimeters. Okay. So I'm almost done. I found side B, and then I just need to find side C. Okay. So side C is missing. I have that the angle is 16, but I need to find the side, right? So I'm going to stay with my anchor that's given to me. So I have 9 over sine of 81 equals C over sine 16. Okay, going to multiply both sides by sine 16, just like we did before. So I'm going to have 9 sine of 16 over sine of 81 equals C. I'm going to pop that in my calculator as well. So 9 sine 16, close parentheses, over sine 81 is 2.512 centimeters. Okay. So that's it. That's what we need to do to solve the triangle. Find all 3 side lengths and all 3 angles. And we did. We found the missing angle and we found the 2 missing side lengths using law of sines. Do you guys have any questions about that process at the moment? Okay, I'm going to leave this up. I'm going to leave this up as a reference for you if you want. And then I'm going to have you all try this next problem. So it's also angle, side. And I'd like for you guys to go ahead and solve the triangle. Make sure your calculator is in degree mode. So if you're using Desmos, make sure you have DEG and not RAD. Okay, so go ahead and get started and ask me questions as you work if you have any. And it's okay to ask me questions. Like, even if you're like, I'm stuck, I don't know what to do, I will help you. All right, so go ahead and get started. It's actually in the Nearpod. So you want to go back to your Nearpod. You can look at the Zoom or the screen as a reference, but the work itself is actually in the Nearpod. Make sure your angle's up to 180 when you find that last angle. What should the third angle on this one be, folks? What do y'all think? If you have, okay, yeah, good. Someone said 130. Very good. Yeah, the third angle should be 130. So that'll help you set up your other proportions. All right, I've got a couple people submitted, so let me give it one more minute. If you've already submitted, you can take a look at the homework. All right, so to help you out with this a little bit, I see we've got the angle, like people are pretty good with finding the angle. So we have, this is 30, this is 20, and then we figured out this is 130 because they all have to add up to 180. So 180 minus 30 minus 20 is 130. And then the angle, the side that you're given is 45 meters over here. So if you have a triangle A, B, and C, you have all three angles and you have side little a, side little, and what's missing is side little c and side little b. Okay, so we're going to use that law of sines to figure out what the missing side lengths are. So your proportion would be a over sine a equals b over sine b. And then you could set up another proportion, a over sine a equals c over sine c, and then solve that way. Okay. All right. All right, so we've got 4 people submitted. That's great. Okay. All right, let me go ahead and go forward. I know that I think my Nearpod is lagging a little bit because I see people doing a great job setting up. So what I'm going to do is I'm going to share the slides again. Or I think I'm sharing the slides. Okay. So these are the slides, and then this is the review of the problem. So to solve the triangle, we already talked about how angle C would be 130 because you have to, these all have to add up to 180. So 180 minus 20 minus 30 ends up being 130. Okay. All right. So to set up your proportions, you have the opposite sides that you have are A and A, right? So you have angle A and side A. So we'll set it up as 45 over sine of 30 equals B over sine of 20. Multiply both sides by sine of 20, and we get 30.782. Okay. And then same for C. We're still going to use what we're given as an anchor, 30 and 45. Okay, so 45 over sine 30 equals C over sine of 130. 45 sine 130 over 130 is C, so that's 69.944. Okay. All right. How do we determine where lowercase c and b is? So typically the way that it gets labeled is if you have angle C, the opposite side of angle C is the side C. So see how like here you have angle C that's labeled in black here. Opposite angle C, we just call that side C. So that's a convention of how they label it. Okay, anything else? Any other questions? Okay. waiting for the chat. Can we do another one? I don't have another one in the Nearpod, but I'm going to give you guys workshop time to, there's some in the homework. Okay. Okay, any other questions about this one? I know someone asked if we could do another one. There is one in the homework that you can try, but I want to make sure that I teach you guys this as best as we can. Okay, I'm going to leave the Nearpod up for a bit, and I want to go over the area of a triangle formula, and then we'll do one of those, and then you guys will have some time to do your workshop. So if you have the area of a triangle, and this is another formula that you're going to get, it's a little bit easier than law of sines. So if you have, let me do this on the paper again. Okay, so do that way. Okay, so if we have, say we have triangle A, B, and C, okay? And you guys know that basically the area of a triangle is 1/2 base times height. That's like your typical geometry formula. But if you're not given the height, right? Let's say we have to draw the height. So we know we have side B. This was the question of how do we label. Opposite angle B is little b. Opposite big C is little c. Opposite big A is little a, right? Okay. So we know that we have a base, right? That's side B. Okay. But if we don't have the height, angle C would give us the height, right? Because the sine of C is h over a, right? So this is like your angle C, your theta C. Sine of C is, this is a right triangle now, opposite over hypotenuse. So sine of C is h over a. And if you solve for h, that would be a sine of C equals h, okay? So basically what this formula is if you have side, angle, side, right? You know that you have two sides and their included angle between them. 1/2 of base times height. Height is just a sine of C. So this is the same formula, 1/2 base times height, but it's a sine C in place of height, okay? So I'm going to do an example with you from the slides. So the slides example is if real estate, let's say we have a real triangle. So you have real estate is $400 per square foot. How much would you pay for the triangular property pictured? Okay, so we have it's triangle A, B, and C. We have 4 feet here. That's a small property. 12 feet here, and then 40 degrees here. Okay. So again, you can only use this formula if you have side, angle, side, and you do, right? You have a side, and then the angle between them. So you have SAS, so that means we can use the triangle formula, right? 1/2 A, B, sine C. We have A is 4, B is 12, and then sine of 40 degrees, okay? So then all we need to do is plug that in our calculator. So we have 1/2 times 4 times 12 sine of 40, which is 15.426 square feet. And then I think the problem says that the property is $400 per square foot. So you would pay, 400 times 15.427. So that would give us $6,170.76 for that property. Okay. So just to recap, you can use the area formula when you have side, included angle, and side, just 1/2 AB sine of C. Okay. So I'm going to go ahead and progress to this next, try it. I want you guys to try this one. Okay. You have triangle ABC, you have 10, 25, and 7. And I'd like you to just take, this should be quick, just sort of like this, try to find the area of that triangle. Go ahead and get started in the Nearpod, please. Thank you, Trish, for getting started. I appreciate it. And I'll leave the screen share up so you can get help if you need it. All right, thank you, Yafet, for getting started. Thank you, Nathaniel, for getting started. Awesome. Thank you, Jefferson. Thank you, Brianna. Is it showing up okay for you guys? Awesome. So you have side, angle, sides. You have everything you need to just drop it into the formula. All right, if you have one of these and you're trying to switch from radian mode to degree mode, you would just go to mode, and then the third thing down is radians to degrees. So just highlight to make sure degrees is highlighted. You're welcome. All right, about another minute. See, people have set it up beautifully. So guys, if you don't have, I don't expect people to have TI-84s. Desmos will be fine for this unit. So if you go to desmos.com/scientific, it's free. It's pretty easy to use. You just have to make sure this switch goes to degree mode and not radian mode. Okay. In fact, let's actually use this to solve our problem, right? So I'm leaving the Nearpod open. I know some people are still working, but a lot of people have submitted. So let me go ahead and move on because I do want to give you that workshop time to practice. So 1/2 AB sine C, remember that has to be side angle side. You have that here, right? 10, 25, 7. So you have side angle side, okay? So we can actually just go ahead and plug these in. So 1/2 times 10 times 7 times sine of, I think it was 25, right? Times, yeah, 25 degrees. 25 degrees. Wow. 25. There we go. Okay. And it gives you an area of 14.792. Notice that if you were in radian mode, it would give you the wrong area, right? So if you were switched to radians, you'd get a negative answer, and you don't want that. We want to make sure we're in degree mode, DEG. Okay. So this calculator is pretty good. It's free. You can always use it. It's the one I always have the Nearpod link to. Okay. Okay. So if we rounded it to 1 decimal place, like I think it said to, you would just get 14.8. Okay. So side angle side, 1/2 side side sine angle. That's it. All right. Okay. Any questions right now that I can answer for you? How do you know what the lowercase letters are? So you label them to just be the opposite, right? So here's angle A. This is the side opposite A. That's going to be little a. Okay. Here's B. Opposite B would be side B. Okay. So that's how you know what the little letters are. The little sides. Oh, you mean how do you match it up? Someone asked, how do you know what the lowercase letters are for the number? Is it like, are you asking like how you know you have side angle side? Okay, let me do this. Oh, what A, B, and C equal. Okay, so because we talked about how opposite A is little a equals 7, right? So if you look at this slide, that's what it says here. Little a equals 7. Opposite B is little b. So little b equals 10. So the way you do it is you just, whatever your angle is, like if your angle is labeled M, like big M, the side opposite that angle would be little m. Okay. And sometimes it's helpful to do just like what we did in the stuff that I did on the document camera, just label them right off the bat. Like this is little a, this is little b, this is little c, before you do any work. Because that way you can set everything up correctly. Okay. All right, let me give you guys some workshop time. The homework is published. You can start taking a look. I think we'll have about 6 minutes or so for y'all to get started. Ask me questions as you have them. This is linked in the Nearpod, so you can just click on it right away and just open it up if you want. And I think 1 and 2 should be, I think, our law of sines. And then at 9:55, we'll go to the check for understanding. All right. Any questions on the homework for me right now? Okay. So what I want to do, you are welcome if you want to get started on the exit card. All right. So what I wanted you all to take away from today was that the law of sines can be used to solve a triangle when you have ASA, AAS, or SSA, and that the area formula is useful for finding the area when only two sides and the angle between them are given, SAS. So that's what I wanted you all to get out of today. So if you are ready to complete the exit, start doing the exit card, it's linked in the Nearpod. So you can get started on that whenever you're ready. All right, so it's 9:54. So if you have not started the exit card, I think you should start so that you can leave class on time. So go ahead and start the CFU that's linked to the Nearpod when you have a chance. Feel free to use the slides that are in our resources page if you would like, or your notes.